Today, the topic of discussion is circular motion. This is the very important topic of overall physics syllabus. Circular motion and rotational dynamics covers much more coverage of marks in MHT, CET, NEET as well as JEE, and that's why we are going to study this topic very carefully at micro level. So let's start with the topic circular motion. So let's start with the definition of circular motion. The motion of object along circumference of circle is called as circular motion. The motion of object along circumference of a circle is called as circular motion. This is first important definition for circular motion. Now, when object is moving along circumference of a circle, we have to consider some important terminology regarding circular motion of an object. Suppose that an object is moving in anti-clockwise direction along circumference of a circle. On the circumference, let this is the position of the object. This is the position of the object. Point A. Now, when object is moving along circumference of the circle, the vector drawn from the center of the circle to the position of the particle. The vector drawn from center of the circle to the position of the particle is called as radius vector. Radius vector. This is important term regarding circular motion. What is radius vector? A vector drawn from center of circle to position of particle. On circumference. This is called as radius vector. So radius vector is very important term. The vector drawn from the center of the circle to the position of the particle is called as radius vector. So for this particular case, OA bar is equal to R bar is radius vector. Radius vector. Now, the important property of radius vector you have to memorize is that radius vector is directed, as it is vector, it has direction, it is directed along radius. As it is directed along radius, we call radius vector as a radial vector. So radius vector is directed along radius and away from center of the circle. This is very important. So direction of radius vector is away from the center of the circle. Radius vector changes direction at every point, but its magnitude remains same. Suppose that object is from point A moving from point A to point B. Let now this object has new position B, say. Then vector drawn from center of the circle to the position of the particle is called as radius vector. Now object is moving from point A to point B on the circumference, and in the same time radius vector has traced some angle theta at the center. Now OA bar and OB bar, these are two different radius vector. OA bar cannot be taken as OB bar because their directions are different, but we can take magnitude of this radius vector OA bar at position A equal to magnitude of radius vector at position B, and that magnitude is equal to radius of the circle. So dear friends, This was the first discussion in which what we have learned. First of all, we have learned definition of circular motion. What is circular motion? Whenever object is moving along the circumference of a circle, the motion of the object is called as circular motion. Radius vector, in board examination, there will be a 2 marks question. Write a note on radius vector, and there may be some MCQ questions at any examination. What is radius vector? The vector drawn from the center of the circle to the position of the particle is called as radius vector. What are the 4 important points regarding radius vector? First of all, it is the vector directed along radius and towards center of the, it is the vector directed along radius and away from the center of the circle. So it is the radial vector. Radius vector changes its direction at every point. So two radius vector are not equal vectors. But radius vector has a constant magnitude and it is equal to, what is, it is equal to radius. So radius vector is very important terminology in circular motion. What we have learned, definition of circular motion, we have learned about radius vector. Now what about the velocity of the particle whenever it is performing circular motion? Whenever particle is performing circular motion, the velocity of the particle at every point is directed along tangent at that point. Listen, whenever particle is moving along circumference of a circle, the velocity of the particle at every point is directed along tangent at that point. As tangent is changing its direction at every point, we can conclude that velocity of the particle performing circular motion at every point, as it is directed along tangent, tangent changes at every point its direction. It means that velocity also changes its direction at every point. And as there is a change in the direction of the velocity, definitely there is a production of acceleration due to change in direction of the velocity. And as there is a production of acceleration, we can conclude that circular motion is always an accelerated motion. So clear? As velocity is directed along tangent, you can make notes of these particular statements, whatever I am talking with you, whatever the lecture I am delivering to you, you can make it, you can revise the lecture 2 or 3 times and make the notes. So as velocity is directed along tangent, tangent changes at every point its direction, velocity also changes its direction. Magnitude of velocity may or may not remain same, that is different thing. Magnitude of velocity may or may not be constant in circular motion, but one thing is there, acceleration is always there due to change in magnitude of the velocity. Change in direction of the velocity. So whenever particle is performing circular motion, velocity always changes its direction and that produces acceleration. That acceleration which is produced due to change in direction of the velocity is called as radial acceleration or centripetal acceleration. So if there is a question that what is the cause of production of centripetal acceleration, the cause is change in direction of velocity. So very important point we have cleared here. Whenever particle is moving along circumference of a circle, at every point velocity is directed along tangent. At every point velocity is directed along tangent at that point. So direction of velocity changes, and change in direction of velocity produces an acceleration that is called as centripetal acceleration. We can draw these particular 2 figures to explain all these particular discussion in the diagrammatic format. As this is point A where velocity is along tangent, so this is velocity VA bar. This is point B where velocity is directed along tangent, so this velocity is VB bar. This is VC bar, this is VD bar, and these velocities are not equal because their directions are different. Their magnitude may be same or may not be same, but direction is definitely not same, and therefore we will not say that velocity vectors are equal. In circular motion, velocity vectors can never be same, and velocity vectors are tangential vectors. This is the very important statement regarding velocity of a particle performing circular motion. The motion of an object along circumference of a circle is called as circular motion. Whenever particle is performing circular motion, the velocities of the particle at any point on the circumference is directed along tangent at that point. As tangent has different direction at different points, velocity also changes its direction at every point, and that's why there is a production of acceleration called as radial or centripetal acceleration, and hence we can say that circular motion is always an accelerated motion. What is radius vector? The vector drawn from the center of the circle to the position of the particle. Radius vector is radial vector. It is directed along radius and away from the center. Its magnitude is same, but directions are different at every point. Then we have discussed angular displacement. Angular displacement is the angle traced by radius vector in a given time. It is equal to s upon arc upon radius. Its SI unit is radian. Angular displacement, whenever it is finite, it is scalar quantity. Whenever it is infinitesimally small, that is tending to 0, it is a vector quantity, and its direction is given by right hand thumb rule. Imagine the rod to be held in a right hand with fingers curled around and thumb stretched along the axis. If curled finger represent direction of circular motion, then thumb represent direction of angular displacement. So this is overall about the first topic of the circular motion. In the next lecture, we are going to discuss angular velocity, acceleration, and different things about circular motion.